Hello everyone. Now we are going to see about the graph data structure. Here we are going to see the given topics as the definition of graph and graph ADT operations and some common terminologies used in this graph ADT so that we can understand the operation done on the graph ADT and a minimal level of applications by using the graph. And then we see about the four common types of graph. At last, the representation of the common type of graph in a computer system. Okay, we go for definition of a graph. So here, the graph is a non-linear data structure to represent the data in a computer system, where the data or informations are represented as the vertices or nodes in a graph. Similarly, the connection between the information or data. The connection means is nothing but the order of arrangements of data is known as the connection or sequence of order of the data or information in a graph structure is known as edges. So that in a graph data structure, the informations are represented as a vertices. In this given example, the data V1, V2, V3, V4 are going to be represented, and those data or informations are arranged in the order from V1 to V2 and from V2 to V3, after the V3, the V4. Such a way, those data are arranged, but these are arranged in non-linear order, means that is linear arrangement. But here, before V1, the V4 is also there, and so on. So that which is known as non-linear data structure. Okay, so this nonlinear data structure is collectively known as a collection of vertices and which is represented by the capital V, and the connection between the data, that is arrangements of data, is represented by the collection of edges, is represented by a term capital E. Those collections, that is collection of nodes or informations, and the connection between the nodes or informations collectively known as the graph G. Okay, still now we have seen what is graph by diagrammatical way. So this is possible to understand only by human, not by the computer system. So how do you represent in a computer system about the graph? Is nothing but only the binary values are possible to represent. So that representation of computer system of a graph is nothing but by two common ways, is nothing but adjacency matrix and adjacency list. Okay. Before this representation, we see the types of operations on graph ADT is nothing but first we have to create a graph and insert the nodes, delete the nodes, similarly traversal the graph ADT, and if there is a path between two data and if there is any vertices are there or not, those are all the common ADT operations in a graph. In a real-time example, we can say the graph ADT can be used to make a path between the locations in a city. For example, in Namakkal, a number of cities are there. Between two places, there is a direct path is there or indirect path. are there. Such applications are possible by the help of graph editing. Okay, so there are different types of graphs, among them four common type of graph. Now we are going to see. Is nothing but the first one is directed graph, and the second one weighted graph, and the fourth one is unweighted graph. Okay, what is directed graph? Given in this example, the first one is known as directed graph, where the edges have some directions. That is, from 5 to 3 there is a edge, but it is a direction from 5 to 3, so that all the edges are having the directions, so that this graph is known as directed graph. Okay, and the another second type of graph is undirected graph. So where in undirected graph there is no any direction between the vertices, so that which is known as undirected graph. That is, a path if there is exist means in undirected graph in both version the path is that is from 5 to 3 also a path, and from 3 to 5, that is vice versa, path is also there. But in a directed graph, only a path started from 5 to 3, not possible to come back. That is the meaning of directed graph and undirected graph. Okay. Then the value given to the path or edges means that type of graph, as in the example, is known as weighted graph. Suppose from one location to another location you have to travel means how many kilometers, that is the distance between two places, is represented as a weight. So that this type of graph is known as weighted graph. So here, as in the example, the weight or another name is cost of the path, another name is value of the path. In either way you can represent. Here, from in the weighted graph, from A to B, the value or weight or cost of the path is nothing but 4, and from C to D the weight is 8, and so on. And the unweighted graph, there is a path but directed path, so that which is known as unweighted but directed graph. But there is no weight, even though directed or undirected, there is no cost or weight, that is known as unweighted graph. Such a way, there are commonly four types of graph, is nothing but directed graph, undirected graph, weighted graph, and weighted graph. Okay. So some common terminologies which are used in graph editing operations we are going to see here. The first one, adjacent vertices. It is nothing but the node or vertices adjacent to each other or connected by an edge is known as adjacent vertices. So any nodes, more than one node, are connected by a single edge, that is known as adjacent vertices. And the another terminology is path. Path is nothing but the link between two nodes indirectly, also known as path. And the given example graph, the vertex A to D, there is a direct from A to E, E to C. Some other path is also there. And as in the first terminologies, for A there are three adjacent vertices are there, but for B only one adjacent vertices are there, and so on is given. Okay, what is cyclic path? The cyclic path is nothing but if you start your traversal from a node and go to visit all other nodes and come back to the same nodes means that is known as cyclic path. The starting point and ending point are same means that path is cyclic path. Okay, the next one, degree of the vertex. So here the degree is nothing but number of edges connected to a node is known as degree of vertex. The edges are connected to a vertex, so the degree of vertex. In this example, the degree of A is nothing but 3. Similarly, each and every node such as A and C, those two nodes are having its degree is 3, and D and B are has its degree is nothing but 2. And then the degree has two types on the directed graph, in degree and out degree. They are understand by the help of how many directed paths getting inside to the vertex, that is known as in degree. And similarly, how many direction going out from a vertex is known as out degree. In this example graph, B, if you take a vertex B, its in degree is 1, only one direction getting into the vertex. Similarly, outgoing direction is only 1. So its out degree also 1, in degree also 1. So the in degree of the vertex C is 3, but the out degree of C is 0, and so on. And the representation of matrices, already I told you, there are two types of representation of graph. The first one is adjacency matrix, the second one is adjacency list. So, the four common types of graph, that is weighted, unweighted, directed, undirected. Such a four types of graph, how do you represent in the adjacency matrix and then in the list? We'll see about those two representations. Okay. So adjacency matrices is nothing but the two-dimensional matrices in which the data about the connection between two nodes are stored. So here, based on the type of graph, that is undirected, unweighted graph means there is no cost between in the edges, no cost between the edges. So that is known as unweighted. And similarly, there is no direction, so that undirected. So if there is no cost means what is the value to be stored? Is nothing but the matrix is represented by row-wise the vertex 1, V2, V3, V4. Similarly, column-wise the same collection of vertices to be represented from V1, V2, V3, V4. And the interconnecting cell values either be 1 or 0. If there is a path between two nodes, the value is 1. If there is no path between two nodes, the value is 0. Such a way, the adjacency matrices for undirected and unweighted graph will be represented. Okay, that is here the matrix name is A of two-dimensional A means the graph G is nothing but a collection of vertices and edges. If the number of vertices is n means the how many rows and columns of matrices to be represented to be calculated as n by n. N by n matrices are required. If 4 matrices means 4 by 4 two-dimensional matrices are required to represent this graph data structure. Suppose 3 vertices only are there means 3 by 3 matrices are enough. Okay. So the values either 0 or 1 are used to represent the adjacency matrix of this kind of graph. If there is no cost of edge and there is no direction between the edges. Means we have to specify either 1 or 0 on the adjacency matrices to represent this kind of graph. And you have to note down one important point is nothing but in this adjacency matrix under this directed graph, especially undirected graph, all the diagonal values are 0. Okay. Suppose if put this directional means all the diagonal values are infinity because there is no self loop. So that all diagonal values are 0. And similarly, the main diagonal values are symmetry because undirected graph. Okay, so you put this weighted graph now instead of the value 1, whatever the weight given here is available there. Okay, so from V1 to V2 there is a path. So that the intersecting from V1 to V1 is 1. From V1 to V4 there is no edge. So the intersecting cell from V1 to V4, V1 to V4 is 0. The vice versa is nothing but from V4 to V1 is nothing but this cell is intersecting of V4 to V1. Okay, this value also 0. That is opposite vice versa. Values are equal. That is the main diagonal values are symmetry. Okay. The next type of graph, undirected but weighted graph. So the edges has no direction, but the cost is there for each and every edge. In that, the same matrices are required, that is n by n matrices are required to represent this graph. The totally 5 vertices are there, so that we have to create a 5 by 5 matrices in which the row header to be the name of the vertices. Similarly, the column header, row header also vertices name, column header also vertices name, started from 0 to 4. The intersecting cell value will be fixed on the cost of the edge. If there is a edge between 0 to 1, and you have to identify the value of the cost or weight of the edge that has to be entered into the intersecting cell from 0 to 1. Because there is no direction, the vice versa value, that is symmetric value, also same. That is from 1 to 0 is also same value and so on. Okay, and you have to know all diagonal values in this undirected but weighted graph is known as infinity. Why we fix it as the infinity means is nothing but each and every vertex has no loop. That is, there is no path from it to itself. A cyclic path is there. That cost will be calculated once you've taken some time. But there is no direct path from one to one, but indirect cyclic path is there. Its cost only can be calculated later, so that its cost, that is the diagonal values from 1 to 1, from 0 to 0, from 2 to from 2 to 2, such a due to the cost, that is weighted graph. If it is unweighted graph, these diagonal values are 0 and the main diagonal values are symmetric. There is also, that is from 1 to 3 is 10 means from 3 to 1. 3 to 1 is also having the value of 10. Okay, and the third type of graph is nothing but directed, that is the directed edge is there, but unweighted graph. So how do you represent? If there is a edge from 0 to 1 means the value of z is 0 to 1, the value is nothing but 1, but the vice versa is not same because there is no direction from 1 to 0. So 1 to 0, there is no direction. So its value is 0, which is not symmetric to its 0 to 1 value, and so on. Okay, that is given here. The fourth one is nothing but adjacency matrix for directed graph. Also, the weighted edges are given here. Okay, for this also, as usual, you need the number of edges is 5 means 5 by 5 adjacency matrices to be created, and the column header and row header are vertices name, and intersection cells are have the cost. And here in the previous one, that is directed unweighted graph, there are 0 only came. Yes, that is the 1. If there is a path, the values 1 is came, and all diagonal values are 0. But here the weighted value, so that the diagonal values are infinity, and the directed edges are also available, so that the symmetric main diagonal values are not same. If there is no direction அப்படின்னா, the main diagonal values are same, but it is a direction which is possible from one to another only, not vice versa. Suppose if there is a opposite path given, then only you can have the value, but what is the value given here will be fixed in this place, and so on. Okay. Now we see about the next type of graph representation is nothing but adjacency list representation. This representation uses linked list data structure. Okay, so here, as given in the following example, a graph containing a four number of vertices which are stored in a list, and the nodes adjacency nodes are stored in another list which are connected to the main vertex. This is known as adjacency list representation. Unweighted means the vertices are stored into a list, and the adjacent vertices are stored into a separate list. That list is connected to the main vertex. That is, the adjacency values are stored into a separate list. That separate lists are adjacent nodes which are connected to main node. And the main node 2 is available in the first list. Its adjacent list, that is 2's adjacent is nothing but 3 and 1, which are connected in a separate list, that is having a connection with its main node, and so on. And if a node 1 has its adjacent node as 2 and 3, and the node 2 and 3 also have its adjacent node 1, and so on, because which is undirected graph, and there is a no weight given in this graph, there is a no weight given, so that each and every node has a single part to store the vertex name itself. But if there is a weight given, each and every node has two parts, as in the linked list data structure. One is to store the data or vertex name. Another part is used to store the weight or cost of the edge. Okay. Okay. The same adjacency list how to used for directed edge, but there is no weight, that is cost not given but direction given. So if direction given means one's adjacent node is 3 but not the adjacent of 3 is 1. Only the difference between the previous graph and this one. So the adjacent node of 1 is nothing but 2 and 3, which are stored in separate list, again which is connected to the main node. So one is having its own adjacent nodes as 2 and 3, but 2 and 3 is adjacent is not 1 because a directed edge is there, and so on. The next one, the same list, adjacency list for even directed and weighted graph. Only the difference, a separate adjacent list are created and connected to the main list, but the difference is instead of a single path, there are two paths are created for representing a single node itself. The vertex name. The second path is used to represent the cost value, that is, the path come from the node 1 to 2. So its cost is nothing but 5. So from 1 to 2 a link is there and its cost is stored into the second part of the adjacent node and so on. The last one, the same adjacency list for undirected but weighted graph. So here, as in the previous adjacency list, each and every adjacent nodes are having two parts, but main list have a single part. Okay, so the node 1 has its adjacent nodes as 2 and 3, 2 and 3. But the value between 1 to 2 is nothing but 5. It is stored in the second part. Due to unweighted and undirected, so this is weighted, undirected, the vice versa are same. That is, if there is the adjacent node from 1 to 2 means then from 2 to 1 also there is a direction, that there is a path because undirectional graph. So if there is a path from 1 to 2 and should be a path from 2 to 1 and its cost are same and so on, you have to represent the four kinds of graph by using adjacency list. Thank you.